All right, so let's talk about some of the questions from the second test. So first one here, given a function which define or describes the height of a rock above the ground, a few seconds after it's thrown off a cliff, and we're being asked for the instantaneous velocity, so the exact instantaneous velocity. So hopefully the word instantaneous clues you in the fact that we need a derivative. So if I take a derivative of this function, f prime of t, well, let's try that again. So if I use the power rule here, f prime of t is equal to negative 32t plus 40. And if I want, so this is the derivative, this is the velocity that the rock will have at any time t. So if I want to know the velocity at my specific time equals 1, then I'll substitute 1 in for all my values of t. And I got negative 32 times 1 plus 40. We don't actually have to fully evaluate it, but this is enough to tell me that this first option here is the correct answer. Next question 2. So I want to find the derivative of h. So I'm given a graph that shows me the graphs of f and g over this domain. So I want to know about the derivative of h. So this is a product. So I need to use the product rule to set up this derivative. So h prime of x will be equal to f prime of x times g of x plus f of x g prime of x. But I want to evaluate that at x equals 3. So f prime of 3 times g of 3 plus f of 3 g prime of 3. So we need these 4 pieces of information to evaluate the derivative. So what is f prime of 3? So I wanted the slope of the graph at x equals 3. So that's going to come from this right here. So it looks like the slope is negative 1. And then I need to know what the value of g is at 3. So at g3 should be equal to 2. The graphs actually cross at that point. So f of 3 is also 2. But then what's g prime of 3? G prime of 3 is going to come from this slope, which looks like it's going upward 2 units for after going right by 1 unit. So that slope should be 2. So all told, our derivative is negative 2 plus 4, which is 2. Moving on to question 3. Now we're redefining h to be a composition. So h is equal to f of g of x. So if we have a composition of functions, we need to use the chain rule. So h prime of x is equal to f prime of g of x times g prime of x. Specifically, what's going on at 3. So f prime of g of 3 times g prime of 3. So if we work from the inside out here, what is g of 3? If we remember from the last question, we said g of 3 was 2. So really, this is f prime of 2 times g prime of 3. What is f prime of 2? F is this curve here. So what's the slope at 2? Should be equal to negative 1. And what is g prime of 3? That should be equal to positive 2. So this slope should be negative 2. All right, moving on to question 4. Redefining h again. Now we have a quotient. So we need to use the quotient rule. So what is h prime of 3 going to be? That'll be equal to g prime of 3 times f of 3 minus g of 3, f prime of 3 all over f of 3 squared. So again, let's fill in all these blanks again. What is g prime of 3? So the slope of this graph will be 2. What is f of 3? It's also 2. What is g of 3? They cross there, so that's 2. What is f prime of 3? I believe we said that's -1. Well, these are starting to sound familiar. And then finally, what is f of 3 squared? So we said the f of 3 was 2, which means denominator is squared. So what do I get here? I get 4 plus 2 over 4, so 6 over 4 or 3 over 2. Right? Moving on to question 5. All right, so now I'm given a function or a curve in y and x, and I want to know, so the line tangent to the graph of y intersects the x-axis. Okay, so got a couple of steps to enact here. So the first thing I want to do is I need to know what the line tangent to this curve is. So how do I do that? That is going to come from me doing, taking a derivative. And in this case, I have two functions being multiplied by each other. So I need to enact the product rule. So y prime will be equal to 2x plus 1 prime times e to the x plus 2x plus 1 times e to the x prime. So what is the derivative of 2x plus 1? That is 2 e to the x plus 2x plus 1. The derivative of e to the x is also e to the x. So what do I want to do with this derivative? Well, I need this to find the slope of the tangent line. So I'm going to evaluate this where x equals 1. So that'll be 2 e to the 1. No, I'm sorry. X equals 0. So 2 e to the 0 plus 2 times 0 plus 1 e to the 0. So I get 2 plus 1. I have a slope of 3. So if I want to set this up as y equals mx plus b, I have now found the slope, that's 3. We were given an x value and a y value, so I can solve for b. So y is equal to 1. Actually, making this more complicated than it needs to be, which is fine. Either way, you're going to get to b equals 1, but if I'm given a point where x equals 0 and y equals something else, that is the definition of what a y-intercept is. So I know that my b is 1. So the equation of the tangent line here is y equals 3x plus 1. Not quite done, though. Now I want to know, where does that intersect the x-axis? So x-intercepts happen where y is equal to 0. So I'm going to set y equal to 0 and solve for x. So 0 equals 3x plus 1. 3x equals -1. X equals -1/3. So that is the point where the line crosses the x-axis. All right, and then moving on to question 6, we're supposed to use our knowledge of inverse trig derivatives. So this equation we're given 4x equals sine y. If we leave it in the form it's written in, we have to use implicit differentiation, which you can do. But we can also do a little algebra up front. What happens if I take an inverse sine of both sides? I get inverse sine of 4x equals the inverse sine of the sine of y. So sine and inverse sine are inverse functions, so they will annihilate each other. So what I have there is y equals the inverse sine of 4x. Now I don't have to do implicit differentiation. I can differentiate both sides of this equation with respect to x. Then I get dy dx is equal to whatever the derivative of inverse sine of 4x is. So let's remind ourselves of a fact here. The derivative of inverse sine of x, which is x, is equal to 1 over the square root of 1 minus x squared. So how does that help me with this derivative? So we're going to have to use the chain rule because our inner function here is 4x. It's not simply x. So the derivative of the inverse sine of 4x, or let me just say it this way, the derivative of the inverse sine of something will be 1 over the square root of 1 minus that something, in this case 4x squared. But since that inner function is not simply x, I have to multiply by the derivative of that inner function, so that'll be 4. So if I do a little cleaning up here, I get 4 over the square root of 1 minus 16 x squared. So that is our derivative there. And I believe that's all for part 1. Okay, so now we're moving on to part 2 of the exam. So question 1, the number of baseball hats a company has produced after T hours since opening is modeled by H of T. So H of T stands for the number of hats they've produced. T is the number of hours they've opened. So we are asked about H prime of 2. So if H describes the total number of hats that have been produced T hours after opening, then what does H prime refer to? H prime is the derivative, so that refers to basically the rate of production. At this instant, how many hats am I producing every hour or per hour? So we know we're looking at a rate. So let's look at these 4 choices here. In the first 2 hours, the company's production of hats has increased by 200 hats. The problem I have with this language is that when we say things like in the first 2 hours, it very strongly implies that I am looking at an average rate of change because I'm looking over the interval of the first 2 hours. So because of that, I'm going to throw out these first 2 options. All right, what's the third option? 2 hours after opening, the company had produced 100 hats. I don't think that's what's happening either because that one sounds to me like H of 2 equals 100. Because this is not talking about a rate. This is talking about a production, like this number of hats that I've made. So I'm going to throw this one out too. Let's make sure the last one makes sense. 2 hours after opening, the company's production of hats was increasing by 100 hats per hour. I believe that's a good representation of what the derivative means here. So if H stands for the number of hats and T stands for the number of hours that have passed since I opened, then 100 hats per hour makes sense in terms of a unit, but it also makes sense in terms of what this, mathematical model is referring to. All right, question 2. Which function represents the limit as x approaches 3 from the right, being equal to 0? So let's look at all 4 of these. So as I approach 3 from the right, I think on this line, I'm going to be approaching this open dot. Does that look like as x approaches 3 from the right, y approaches 0? That sounds good so far. Let's look at the other choices just to be sure. If I follow x equals 3 from the right, if I approach x equals 3 from the right, I don't believe I'm going to get a limit of 0. I think I'm going to get a limit of 3. So I'm going to throw this one out. How about over here? We actually have a function that's continuous at x equals 3. So because of that, I can just look at the value of this function x equals 3. Looks like it might be 3, but it's clearly not 0, so I'll throw 3 out. And then how about 4 here? As x approaches 3 from the right, so basically if I look at this table going right to left, does it look like my limit is 0? I don't think I have enough information to tell you. It might be, but certainly is not as conclusive as what's going on in Roman numeral 1. So I think that's the only one I'm going to take. All right, moving on, question 3. The graph of f prime of x. The derivative is shown here. So this is f prime. What graph could be f of x? So one thing I like to look at is I like to focus first on where the derivative is equal to 0. So that's at x equals -1 and x equals 1. So if the derivative equals 0, what does that mean the graph of the function needs to look like? It means I need to have horizontal tangent lines at x equals -1 and x equals 1. C does. So C is a good candidate. What about A? A does not have a horizontal tangent line at -1 or 1. So I don't like that. B has horizontal tangent lines at -1 and 1. So I think I need to consider B. D is a straight line. D has no horizontal tangent lines anywhere. So for that and lots of other reasons that I don't need to get into, we can throw out D. So now let's try to rule out either B or C. So what is happening between -1 and 1 on my derivative graph? I have negative values. So my derivative is negative. What does it mean for the function f if the derivative f prime is negative? That means my function needs to be decreasing between x equals -1 and 1. I don't believe that's happening at all in C. In fact, we have an increase over that interval. So I'm going to throw out C. Does B make any sense? I believe so. Everywhere from -1 to 1, I have a decrease. So I think I have seen enough evidence to accept B as my correct answer. All right, question 4. For this function, the mean value theorem for derivatives will be satisfied by which coordinate? So, first of all, we should make sure the the mean value theorem should even be something we can look for. So, is this function continuous on the the closed interval AB? Looks like it is. Does it look differentiable on the open interval AB? I don't see any hard corners. I don't see any vertical tangents. I feel good about that too. So just a little check to make sure that the mean value theorem is something that is worthwhile to talk about. So what does the mean value theorem say? It says that if I look at my interval AB, the average rate of change over that interval. No, so let's talk about that first. What is the average rate of change on this interval? Let me try futilely to make a straight line that actually joins those points. That's about as good as I can do. So mean value theorem says that this average rate of change, there has to be some point on this graph where the instantaneous rate of change is exactly equal to the average rate of change. Or another way to think about it, which is, kind of the graphical way to think about this. The tangent line at one of these points needs to be parallel to this average rate of change, the secant line. So based on that, I think I can throw out C4. C4 is going to have a negative tangent. I clearly am looking for a positive tangent. For that reason, I think I can also throw out C3, which looks like a maximum, so it'll have a horizontal tangent. And I believe it's C2 that the tangent is going to be roughly horizontal as well. I think the only one that even comes close to making sense is C1. So I'm going to accept C1 as my correct answer. Oh, question 5 here. So we are told that f prime, and f double prime are continuous on this interval AB. Okay, so then which of these are true? Then there is a number C in AB with f prime of C equals 0. I don't think we can say that. If you say the derivative is continuous on an interval, but doesn't mean it's ever 0. I'm going to throw that one out. Joe, I'm looking at my choices. I might be because eliminating A means the only thing that's left is C. But let's make sure. I think for the exact same reason I just said, f double prime of C is equal to 0. Let me draw a graph here to kind of refute both of these points. What if I have a graph that looks like this? Actually, that's not even convincing enough. So what I've tried to do here is draw a graph that, let's say the interval is from here to here. What I've tried to do here is draw a graph that is increasing everywhere and concave up everywhere. If that's true, there's no way that I can have a place where the derivative is equal to 0, and I can't have a place where the second derivative is equal to 0. So I'm going to throw out B as well. We already suspect C is right, so let's move on to D. F of C as the maximum value of F on AB. There's the number C. I believe D has to be true, which gives me pause. So let's just go look and see. The instantaneous rate of change of F at x equals C is equal to the average rate of change of F on the interval. This should be it. So this right here is the mean value theorem. We know that one's true. So I want to go back and revisit this. I still feel like because A was no good, then C is the only one that fits, but the one I'm giving, it's giving me positive D. Basically what D is saying is there has to be a maximum value of F on the interval. I'm trying to think about why that's false. And the only reason I can think of that might be false is that maybe that point C is not unique. Oh, here's what. It says that C is on the open interval. I'm going to direct you to the graph I just drew. If here's my A and here's my B, I think the graph I drew you, the maximum value would not be on the open interval. The maximum value would be at x equals B. So because of that, it would not be, I would not be able to find the C here. So I feel even better now about saying that C is the correct answer. All right. Final question in part 2 here. The balance in a savings account 2 years after depositing $5,000 is given by this formula. At what rate measured in dollars per year is the balance of the account changing at 10 years? So the word rate, and also going to circle or underline dollars per year. Those are both pretty strong clues that I'm looking at a derivative. I don't see the word instantaneous, but another thing I want to point out here is that at T equals 10 years, not over the first 10 years, or not, it doesn't, there's nothing here to signify a spanning like interval. What I'm giving here is I want to know the balance of the account at this one time. So I think hopefully those 3 clues are enough to convince you that what we're looking for here is a derivative. So now what I would like to find is this derivative. So this is an exponential function. So how do you take derivatives of exponential functions? When we take a derivative of an exponential function, our derivative always contains the exponential function. So I'm going to have 5,000 e to the 0.075 t. I have a bit of a chain rule situation here because if I look at this as the inner function to the exponent, I have to multiply by the derivative of that. So that is going to be, that's linear. So the derivative of that is going to be 0.075. So that's the derivative, and I'm not going to simplify just because the answers don't have it simplified. So now what do I do with this? I care about the time at a specific, or the rate of change at a specific point. So that will be B of 10. If I evaluate this derivative at 10, what do I get? I get 5,000 times e to the 0.075 times 10 times 0.075. And I believe this looks exactly like which one? This looks exactly like C. So this is my final answer here, even though we're not totally cleaning that up, that is the correct answer for the derivative. All right, moving on to part 3 here. So I have this curve given by, I need implicit differentiation here because I cannot isolate y. Even if I could, implicit differentiation is available to us, so we have a way to find these derivatives without having to worry about doing that algebraic manipulation if you want to. So we're asked to identify the correct first step here. So let's just take the first step and see what we come up with. So the derivative of y cubed, first I have to differentiate that with respect to y. So that'll be 3y squared. And then I have to keep following the chain rule. So I'm going to multiply that by dy dx. The second term is going to involve the product rule. So I'm going to split these up into two functions, 3x squared and y. So derivative of 3x squared is 6x. Leave the y intact, and then plus 3x squared dy dx. And then what's the derivative of 9x? That is 9, negative 9. And then the right-hand side is a constant, so that derivative is 0. So which one of my choices looks like this? 3y squared dy dx plus 6xy plus 3x squared dy dx minus 9 equals 0. That looks just like my first choice. So moving on to part 2. The value of a 2019 SUV can be modeled by this function. Where t, or so basically 2019 is our reference time, and t is the number of years that have elapsed since then. So first thing is, what is v of 3? So to find that numerically, I can plug in 3 for t in the original equation. So 31 times 0.75 to the power of 3. And let's get you a good number here. And what I'm getting here is, I'm going to round to the nearest dollar. This is in thousands of dollars, right? So I'm getting $13,078. So what does that mean? That means that 3 years after 2019, so in 2022, the value of this SUV will be $13,078. All right, next question here. What is v prime of 3? Before we find that, we should talk about what v prime of t is. So this is an exponential function. So 31 times 0.75 times t. So I think I said in the last question that anytime you take the derivative of an exponential function, it will contain that exponential function. This is not, so my base is different from e, so I have to observe this. I have to multiply this by the natural log of 0.75. So if I want to evaluate this at 3, 31 times 0.75 to the third power times natural log of 0.75. And what does that come out to be? All right. I am getting a numerical value of negative 3.762. What does that mean? Well, this is a rate of change. So let's first assign units to it. What is V measured in? That's measured in thousands. Yeah, let's not be too cute with the abbreviations. Actually, I'll say this as dollars per year. And I'll change this from 3.762 to 3,762. So what does this mean? So the rate of change is negative $3,762 per year. So basically in 2022, at that instant, so let's say the beginning of 2022, this SUV is decreasing in value at an instantaneous rate of $3,762 per year. So this is part B. And then part C, using your knowledge of calculus, write a few sentences in support of or in opposition to the following statement. from a money standpoint, it's best to keep the SUV as long as possible. Here's the thing, I think you can justify both standpoints. As I say that, I can't think of a reason why I would be in opposition to this statement, but I'll give you my first impulse as to why I agree with this statement. So, and we want to use calculus to justify our answer. So if I look at the derivative, so I'm going to box that in too. If I look at this derivative, one thing I want to point out is that the natural log of 0.75 is a negative number. Also, 0.75 to the t is a positive number. 31 is a positive number. So what does this mean? This means your derivative is everywhere negative. If my derivative is always negative, that means that as soon as I buy this car, it is always going down in value, which is pretty much true for, any, I don't want to say any, but it's true for the vast majority of cars you'll ever own. So because of that, no matter when you sell it, you're going to sell it at a loss. So you might as well get the most use out of it you can. So I think from that standpoint, since you're never going to make money on it, you might as well use it for its purpose as long as you can. But like I said, if you can justify using some kind of mathematical reasoning, your answer, I'm happy with it. All right, question 3, given f of x equals natural log of 2x, find the slope of this function. So let's write down a fact. What do we know about the natural log or the derivative of natural log of simply x? That's equal to 1 over x. So we can use the chain rule here to find the derivative of natural log of 2 of x. So using this fact here, what's the derivative of the natural log of something? Well, that'll be 1 over 2x. My inner function is 2x. But what's the derivative of that inner function? It's 2. So the derivative here will be 1 over x. And this is kind of probably a counterintuitive thing. So the derivative of natural log of x is 1 over x. But now I have the derivative of the natural log of 2x. And I'm also saying that's 1 over x. Seems a little strange, but that is, call this f prime of x. That is absolutely the case. So this is my derivative in general. So what's the derivative equal to at f prime of 1? That'll be 1 over 1, so 1. And what else? Got 2 more questions. Okay. You are boiling 4 cups of water to make hard-boiled eggs. The table shows the temperature of the water in degrees Fahrenheit. Assume the temperature of water as a function of time is differentiable. Okay. One thing I want to make clear is I don't think it matters so much for this question, but if your function is differentiable at a point, it must also be continuous there. So we can say safely that this function, since we're being told it's differentiable, from 0 to 9, from t values equaling 0 to 9, that whole interval, it's going to be continuous at over that whole interval as well. So which expression best represents f prime of 6? So what is f prime of 6? So here we're kind of harkening back to the limit definition of a derivative here. So I'll write that down first. F prime of 6 equals the limit as h approaches 0 of f of 6 plus h minus f of 6 over h. So one thing I'm sure this calculation looks familiar to you at this point, but let's focus on the limit operator. What does this signify? It signifies that I want h to be as close to 0 as possible. So I think all of these give you, to some degree, some rate of change that contains t equals 6. But I think we want to look at the one that has the smallest interval, and also includes t = 6 as a base point. I think that's this first one, because this is going to be an interval of 1 hour, no, 1 minute. So this is an interval of 1 minute, as opposed to this interval for choice 2 is 3 minutes, 2 minutes, and then this last one will be the worst, because that's just taking the average rate of change over a full 9-minute span. So that's the first choice, is the best there. Finally, question 5. Is there a time over this interval for which f prime of t = 30? If no, explain why not. If yes, identify where. Okay. So, is there a time where the derivative must equal 30? So, one thing we covered in the last question, didn't really come up then, but we covered it. This function f is continuous and differentiable on the interval 0, 9. So what does that mean? That means the mean value theorem applies. So if we can show somewhere that the average rate of change is equal to 30 degrees per minute, then that means over that interval, you definitely have a point where the derivative, where the instantaneous rate of change is 30. So let's do this. Let's find the average rate of changes here. And I think we can say this verbally. Let's look at the first 2 minutes. Temperature increased by 10 degrees over a period of 2 minutes. That's an average rate of change of 5 degrees per minute. So one thing I want to point out here, there could be a point in that first interval where f prime of t is equal to 30. By no means can I guarantee that. So let's keep looking. What about from 2 to 4? That's 2 minutes, and the temperature increased by 60 degrees. So let's write that down. F of 4 minus f of 2 over 4 minus 2 equals 150 minus 90 over 2. 60 over 2, that's 30. The average rate of change over this interval 2 to 4 is 30. The function that describes this change, or this covariation, is continuous and differentiable. So the mean value theorem applies. So on this interval 2 to 4, so 2 is less than t, which is less than 4. On that interval, there must be a place. There must be an exact point, an instant, where f prime of t is equal to 30. So we're basically done there. If you want to, I mean, we could probably look through the table and maybe there's another place where this happens, but even if there's not, we already guaranteed, we already found like the one point, at least one point where this happens.